Okay, now we're going to talk about double angle formulas and half angle formulas. And just like the formulas for sum and difference, we can use these formulas to evaluate trig functions, to make substitutions to solve for equations or prove identities. And so in the first example, we have to find three things. We need to find sine 2x, cosine 2x, and tan 2x given this information here. Now the first thing I want you to do, because this is really important and this can screw you up if you don't do this, always make sure you know what angles you're dealing with and what quadrant those angles are in. So if you look at the first part, we got to do sine 2x first. So I have sine 2x, and using our formula up here in the shaded blue box, x2 times sine x cosine x. So in this problem, what we're dealing with is we're trying to evaluate sine of 2x, but we're using the angle x to do that. So I need to know what quadrant angle x is in. And given the information that we have here, I have the tangent of angle x is negative, and I have the cosine of angle x is positive, so that tells me that angle x has got to be in quadrant 4. Okay, so I need to figure out, they don't tell us this information, but we can figure it out by drawing our triangle and coming up with our trig ratios. I'm going to draw a triangle so I can figure out what sine of x is and cosine of x is. So I'm going to make my triangle. Here's my angle x. I'm not going to worry about the negative. I just need to make sure I keep track of what quadrant I'm in. Tangent is opposite over adjacent. So the opposite side of x should be 1 and the adjacent side of x should be 3. Then using Pythagorean theorem, we can find that the hypotenuse is the square root of 10. So now I'm going to use this information to find my values for sine x and cosine x. Now sine x in the fourth quadrant is going to be negative. So when I look at my triangle, sine is opposite the angle over the hypotenuse. So opposite over the hypotenuse, 1 over the square root of 10. And I want to make sure that that's negative because we're in the fourth quadrant. Cosine of x is the adjacent side over the hypotenuse, and cosine in the fourth quadrant is positive. So this is just going to be 3 over the square root of 10. Now when I multiply that all together, I get negative 6 over 10, which I can reduce as negative 3/5. So sine of 2x is negative 3/5. Okay, now let's look at doing cosine of 2x. Now, cosine of 2x has 3 different equations you can use. Here's the 3 right here. It doesn't matter which one you use. You should still come up with the same answer. However, there may be times where one's easier than the other, depending on what the situation is, but you can use any of them. I'm just going to stick with the first one. I'm going to use cosine squared x minus sine squared x. We know from doing sine 2x that cosine is 3 over the square root of 10. And I got to square it because it's cosine squared. And from the previous example, I know that sine is negative 1 over the square root of 10. And I got to square that. And that's going to give me 9 over 10 minus 1 over 10, which would give me 8 over 10. And I can reduce that to 4/5. So the cosine of 2x is 4/5. Now for the last one, we got to find tangent of 2x. Here's the formula for tangent of 2x. We have 2 times tangent x all over 1 minus tangent squared x. So tangent x was given to us in the problem. It's negative 1/3, but we can still find it from the triangle if we want. Let's see. So we have 2 times tangent x is negative 1/3 all over 1 minus negative 1/3 squared. So that gives me negative 2/3 all over 1 minus 1/9. Now 1 minus 1/9 would give me 8/9. And if I have a fraction divided by a fraction, I'm going to flip and multiply. And after I flip and multiply and I reduce, I'm going to get negative 3/4. So tangent of 2x is negative 3/4. So we used our triangle with angle x to find our trig functions for 2x. Okay, and the next example is given information about angle A so that we can make our triangle, but then asking us to find sine of 2A. And it's telling us that angle A is in the 4th quadrant. So we can make our triangle. Here's angle x. Sine is opposite over hypotenuse. And if we use Pythagorean theorem to find the other leg, we would get that the other leg is 5. Okay, so we have sine A. We know that angle A is in quadrant 4, which means sine is negative, cosine is positive. Using our double angle formula, because remember what we're trying to find is sine of 2 times angle A. Whoops, and I just realized I labeled that as x and it should be angle A. Let me fix that. We're trying to find sine of 2A, so we're going to use our formula. Sine of 2A is going to be 2 times sine of angle A, cosine of angle A. Now they've given us sine A, that's negative 12 over 13. But if that's not given to us and we have to find it from the triangle, we have to remember to stick the negative in front of it because we're in quadrant 4. Cosine of A is going to be adjacent over hypotenuse. And that's going to be positive because cosine is positive in the 4th quadrant. And when I multiply that, I get negative 120 over 169. And that doesn't reduce, so this is my final answer. In the next example, it's asking us to write an algebraic expression in terms of x. So here's what we're trying to rewrite. Sine of 2 times tangent inverse x. Now remember that when we're dealing with inverse trig functions, this is really, we'll call it angle theta. So really what we're trying to do, they just wrote it in a different way, is finding sine of 2 theta in terms of x, and we define theta as the inverse tangent of x. Now we can rewrite that without the inverse, and we can say, well, the tangent of theta is x, or x over 1. And then we can use that to make our triangle. So let's let this be angle theta. And we know that tangent is opposite over adjacent. So this is my opposite side, this is my adjacent side. And then using Pythagorean theorem, we could get the length of the hypotenuse. That would be x squared plus 1, and then square root it. So going back to our double angle formula, sine of 2 times theta would be 2 times sine of the angle, cosine of the angle. Now looking at our triangle that we set up, I can find sine of the angle. Sine is opposite over hypotenuse. So that would be x over the square root of x squared plus 1. And cosine is adjacent over hypotenuse, so that would be 1 over the square root of x squared plus 1. And when I multiply this all together, on the top I get 2x, on the bottom I get x squared plus 1. So this is my expression, sine of 2 times inverse tangent of x, written in terms of just x's. Okay, in the next example, we need to simplify 2 times the sine of 67.5 degrees times cosine of 67.5 degrees. And so we're going to write this as one trig function. And if you notice, if I think of this as angle x, I would have 2 sine x cosine x. And if you scroll back up and you look at your equations or your formulas in your blue shaded box, that's this formula right here. 2 sine x cosine x is equal to sine 2x. It's a double angle formula for sine. So scrolling back down, this is equal to sine of 2x. Well, since we labeled x as 67.5, we have 2 times 67.5 degrees. That would be sine of 135 degrees, because you take 2 times 67.5, and if you look at your unit circle, and I find my y coordinate at the terminal point when I swing out 135 degrees, you're going to get that that's the square root of 2 over 2. Okay, next example, same thing. We want to simplify this using our double angle formulas. So I'm going to label theta over 2 as my angle x. So I have cosine squared x minus sine squared x. And if you scroll up and you look at your shaded box with all your formulas in it, that would be this formula here, which is equal to cosine of 2x. So I'm going to rewrite, this is going to be cosine of 2x. Well, we said x is equal to theta over 2. So this is going to be 2 times theta over 2. So this is going to be cosine of just theta. So this is your final answer when we simplify the expression cosine squared of theta over 2 minus sine squared theta over 2, and we use our double angle formulas to simplify it.